Okay, today we're gonna solve triangles, and we're gonna solve for angles and for sides, angles and sides here. And so far today, we are only gonna work with right triangles. And we're gonna first solve for sides, solving for sides. Now, the thing about triangles is they're a very limited shape. What I mean by that, when you look at a triangle, there are always only 3 sides and 3 angles. Okay, 3 sides and 3 angles. And as sides change, angles change. And as angles change, sides change. So the idea is that everything, as it changes, moves everyone else. So there's a relation to it. And the thing is, it's a predictable relationship. So we have 3 sides and 3 angles. So our goal today is this. Given enough information, we can solve that triangle. And today, what we need, so this is what we need 3 bits of info about the triangle, and then we can dox it. We can find out everything else we need to find out about the triangle. And then we can tell you everything else. It means if I give you 3 bits of information about the triangle, I can tell you everything. Okay? And unfortunately, this is like internet stalking, not like I would know anything about it. But if I just have some key bits of information, that's enough. We can find out who you are. Dox you. There's one kid once, like, Mr. Ko, do you live at blah, 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 blah address? I'm like, oh, crap. They found out where I live. Okay, so first we're going to start off learning about the skill of doxing the triangle by just working with right triangles. So I'm going to give you guys a couple of parts. I'll call this 1 and 2 are my sides of my triangle. So I would like you guys to notice I know 1, 2, 3 pieces of information of the triangle. I do not know 1, 2 angles and a 3rd side. Okay, I want you guys to realize I know 3 bits of information and I am missing my 3rd side. I can draw another triangle. Okay, let's just move on with this one. So have you guys seen this shape of a triangle before? A triangle, a right triangle with sides 1, hypotenuse 2. Does that seem familiar to us?
Yes.
Yeah. This is our super special triangle. This is our 30, 60, 90 triangle. Okay. And since we know this, we can fill in the other parts. We know this is 60 because 60 always goes next to the 1. That means this other angle has to be 30 because all angles have to add up to 180 inside a triangle. And the 3rd side is square root of 3. If we didn't know that, we could use a Pythagorean theorem. A squared plus B squared equals to C squared. Let me write that a little nicer for you guys. Pythagorean theorem. So where you can say this is A, B, and C. Just double check. A squared plus B squared equals to C squared. We can solve for B. And B is equal to plus and minus square root of 3. But since this is the side of a triangle, we can't say that's negative. So it's just going to be square root of 3, which is what we said it was going to be. So we've worked with triangles already, 30, 60, 90. Now, my question is, what if I only gave you 2 bits of information? Would that have been enough? I can draw the same triangle. And let's say I told you it was a right angle and that this side was exactly 1. So we know 1 bit, we know 2 bits of information. Would that be enough? Imagine if you're hanging out with some friends and you see a guy you like. And you say, oh, let me ask my friends if they know who he is. So you tell your friends, oh, do you guys know this guy? I just saw him. He's a guy, and he's tall. 2 bits of information. Is that enough? If you go the other way and you say, oh, do you guys know this girl? She's pretty, and she's a girl. That's it. No other information. It is not enough information. What happens is, if I don't give you enough information, this could have been a 1, 1 square root of 2 triangle. So our minimum need is that if you give me 3 bits of information, I can dox this triangle. And let's go ahead and look at another one now, not a special triangle anymore. So here we go. I'm going to give you one with angle. Call this a 20-degree angle. Call this a right angle. And we're going to call, we'll say this is, call that 4. And we're going to look for x, solve for y, and z. Okay, I'll give you 3 things. We're going to solve for x, y, and z. X and y are sides, and z is an angle. Hopefully you can see that. Now, here is the way I like going about it. First, how many angles are inside a triangle? Well, there are 3 angles, and if you give me 2, we can find the third, because all angles inside a triangle add up to 180. So 90 plus 20 plus z is equal to 180. So 180 equals to 110. Z has to be 70 degrees. So let's fill that out. This is 70 degrees, not the side, an angle. So oftentimes the angles are the easiest parts to solve because we know they always add up to 180. Pause. Okay, so the angle was easy. Now, that's the thing I want to tell you. If you know 3 bits of information, for every 3 bits, 2 of them are either going to be 2 sides or 2 angles. Okay, 2 sides or 2 angles. So in this case, we knew 2 angles. That means I can find the third one very easily. If I was given 2 sides, I can find the third side really easily. The angles would be harder. In this case, the sides would be harder. So just be okay with that. If I know 2 angles, the third angle would be easier. If I knew 2 sides, the third side would be easier. Okay? All right, so now here's our tricky part. Do I have enough information to use the Pythagorean theorem? Well, I have 4, and that's it. You need at least 2 sides for the Pythagorean theorem. So I cannot use a Pythagorean theorem here. Okay, too many variables unknown. So instead, we're going to use our trig ratios. And we're going to really just use mainly the 3. Sine, cosine, and tangent. Now again, sine, cosine, tangent are ratios. That means they're fractions. And they're relating the sides together. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And if you have problems remembering that, remember there's SOHCAHTOA, or SOHCAHTOA, some people would say, depending on what part of the country you're in. And remember, this is Pocahontas's cousin, SOHCAHTOA. Princess Pythagoras. So SOHCAHTOA here, we're going to use this as our starting point to find out our missing sides. Okay, so here's what we're going to see. This is how I would like you guys to solve these problems. Looking back at the triangle, you want to figure out which angle you have. And let's start off with this 20, because I know for sure the 20 isn't wrong. Please label the 3 sides, opposite, adjacent, and hypotenuse now. Just do it right now. Once you get used to it, you don't have to label it anymore, but we're going to do that by labeling first. So y is adjacent to the 20. X is my opposite side to my 20. And 4 is my hypotenuse. Please make sure you are clear with those 3 sides, because we need those 3 sides to fit one of these ratios here. The next thing is, which side do you want to solve for first? You tell me. you want to solve for the opposite or adjacent? Because those are the sides we don't know. Let's say you want to solve for opposite. So you pick the side you don't know, and you pick a side that you do know. So that's what I'm going to say. So step one is to label your triangle, just to make sure. You can skip this step once you get better at it. Step two is pick your variable, and then pick a side you know. You want to pick your variable, followed by pick a side you know. In this case, what side do I know? I know the hypotenuse. You guys all agree? Since I label it, it's very obvious. I know the hypotenuse. So we said, I'm going to solve for opposite. I know hypotenuse. Look here. Which of these are opposite and hypotenuse? Sine. Sine is always opposite. You want to stay away from sin, don't you? Well, maybe not, but that's the story. I'm sticking to it. 3, you're going to set up the ratio. So the setup of the ratio is sine of theta. What was the angle that adjacent and opposite was referring to? This was referring to 20 degrees. Sine of 20 degrees is equal to, right? It's equal to, now let's copy the sides. The side is opposite. Let's take a look at my triangle. The opposite side was the letter X. Hypotenuse was the number 4. So we're, no joke, we're just gonna write X over 4. So once you get good at this, this is actually pretty quick. This is an SAT skill that you need to be able to do for the SATs. Okay, this is also from geometry. Now that we set up our ratio, we solve for the variable. Okay, to solve for the variable, I want to get rid of what number? The 20, the sine, or the 4. I'm solving for X, so we get rid of the 4. Opposite of divide by 4 is to multiply 4 to both sides. Let me write it over here so you guys can see what I'm going to do. I'm going to multiply 4 to both sides. So it'll be 4 sine of 20 equals to X. So one thing I want to acknowledge is I do not know what the sine of 20 is. The only angles I know are 30, 60, 90, and 45. Those are the only ones we need to ever memorize. Sine of 20 is now going to be done on your calculator. Let's go ahead and take out my calculator. Nope, not there. Let's do the free scientific one on the phone. Okay, so I'm going to switch over to, hi commercial. Okay, I'm gonna switch over, making sure. One thing you wanna make note, please make sure you are in degree mode here. Look at the top of my calculator, it says DEG. 20 is a degree, so you wanna make sure you're in the right mode. If you're in the wrong mode, you're gonna get the wrong answer. Make sure you're speaking the right language. Okay, so I'm gonna clear it. I'm gonna type it not as I see it, but please be aware, for calculators, I'm gonna type it on the side. I'm gonna write it for you, the steps. I'm gonna write 4 times, okay, times button, 20 sine, and then hit equals. These are the steps I'm gonna type on my calculator. You always type the angle first on these crappy calculators. If you have a nice $10 scientific calculator, you would type sine of 20, sure. But on these freebies, you would type it the way I'm telling you right now. So let's go ahead and follow what I said. 4 times 20 sine, hit equals. The side is 1.36. Rounding up to make that a 7. 1.37. Let me just do that again just to make sure. 4 times 20 sine. Yep, 1.37. So if you look at the variable is X. Oops, go away. Forgot how to get rid of it. Whatever. I'll leave it out for a little bit. We'll use it in just a moment. Okay. So looking back at the triangle on top, x is 1.37. Okay. You can say 1.368, probably a little bit better. But we have solved for x. So not only do we have all three angles, we have two sides. Let's find our third side. We could use Pythagorean theorem now. We could, but I'm going to tell you, using trig ratios, it's actually going to be faster. Let's go through the steps one more time. Steps 1, label, done. Steps 2, pick your side and the side that you know. So we are solving for y now. Let's solve for y. And we're picking the side that I know. This done here. So we're going to solve for my adjacent y over the hypotenuse that we know. Okay? You could choose 1.37 or 1.368. Remember, that's a round off number. So it's already a little bit off already. It's like copying a copy of a copy. So I'm going to go back to the source. I'm going to use this for right here. So looking at sine, cosine, tangent, which of these is adjacent and hypotenuse? Because I'm looking at my adjacent and my hypotenuse now. Which of these are adjacent and hypotenuse? That's going to be cosine. So cosine of theta is equal to adjacent over hypotenuse. So we know what theta is. We said that was 20 degrees. Adjacent is y. I don't know. Hypotenuse is 4. Please take a look at the setup. The important part is the setup. Once I have the setup, everything else is just calculator work. Multiply 4 to both sides. Cosine of 20 equals to 4. Oh, sorry, y. That's a y. And now we're just going to type this into the calculator again. 4 times 20 cosine equals 4 times 20 cosine equals, that gives me 3.75. Whoops. Y is 3.75. I'm going to round up to 76 or 3.759. Okay. I'm going to go ahead and fill out my triangle on top. 3.759. This is 3.759 or 3.76. I recommend that for the most part, do 2 decimals. If you really want to do 3, that's even better. It gets more accurate. Now, this is my claim. Let's see if this makes any sense at all. Okay. Oh, I know what to do. So my question for you right now, does this make any sense? Can I even just look at it to see if it makes sense? Well, you can. Let me ask you this question. What angle is the largest angle? Right angle? That means this is going to open up to become the largest side. What's the next biggest angle? That's a 70. Hey, isn't 3.76 bigger than 1.37? Yeah. So we can do a very primitive way of checking. Small angles, small sides, large angles, large side. And last one, 20, which is my smallest angle, that is related to my smallest side. Small angle, small side, large angle, large side. Now I'm going to do one more check here. Since we have all 3 sides, does the Pythagorean theorem work? Well, let's try. 1.37 squared plus 3.76 squared, would you equal to 4 squared? We're just double checking using a calculator. It's not going to be completely perfect because of round off error. So let's go ahead and try this. So we know 4 squared is 16, okay? That's our goal. Are we going to get to 16? 1.37 squared plus 3.76 squared. Hey, that's pretty close, right? So this is one way we could double check to make sure that we have the correct answers. It'll never be perfect because let me tell you this. Besides the angles of 30, 60, 90, all the other possibilities are always decimal. It's either a decimal side or a decimal angle. Okay, we're gonna do this one more time. Oh gosh, okay, well, we gotta do it quick. Okay, I can draw any triangle in the world. I'm gonna draw it in a funny angle like this, funny way. That's still gonna be a right angle. I'm gonna give you the angle 33 degrees. Okay, now I'm gonna give you the sides. The sides are gonna be 4, and this is going to be, let's say, 6. 4 and 6. Will that be okay? No, don't do that. I'm gonna give you this. Yeah, that'll be 6, okay? Let's see if this works. So first step, I want us to label the sides. Okay, we'll call it X. Wait, I give you too much information. Oops, darn it, crap. 4, just 4, like that, just 4, okay? And then I'm gonna look for X, Y, and Z here. So which of these could I solve for first? Probably Y. 180 minus 90 minus 33 will give us what's left of 57. So we know this last angle is 57. Okay. Now we're going to use the 33. Please name the sides. 4 is opposite or adjacent. I know Z is my hypotenuse.
Opposite.
So, opposite, thank you. So that means X is adjacent. So you decide what you want to solve for first. You want to solve for X or you want to solve for Z? That's solve for X. So if I want to solve for X, you still have to pick a side that you know for sure. That's the 4. So this is going to be adjacent and opposite for sine, cosine, or tangent. Which of these is opposite and adjacent? Well, that's going to be tangent. Now, I wrote this problem a little funnily because it will be different than the other one. So please pay close attention because you just want to copy exactly the way this looks. You have to copy this exactly the way it looks. So tangent of theta, 33 degrees, is equal to opposite on top and adjacent on bottom. Please be okay with that. Opposite on top, adjacent on bottom. And then you might be like, okay, X on the bottom, who cares? Now, this is a problem from Algebra 1. If you remember how to get rid of X's on the bottom from Algebra 1, please take a look at this trick. It's just a swap. You're gonna swap the tangent X around. How does that work? What's the opposite of, so here's a fast trick, okay? You're just gonna write X equals to 4 over tangent of 33. That's the fast trick. You're just swapping these guys around. Now let me slowly explain to you guys why this makes sense. So it works. What's the opposite of divide by X? If I multiply by X to both sides, see how X is on the other side now? Clean. Now how do I get rid of a tangent times X? Opposite of multiply is divide. So that's why it's on the bottom now. But to save time, you could just swap them. You could take the 2 steps to rewrite it or just swap them. Let me say this one more time. Let's do it one more time. Tangent of 33 is equal to 4 over X. You do not want to solve for X on the bottom. That's an Algebra 2 problem right there. Instead, we just flip it. How did I do that? If I multiply both sides by x, x is now on top. And I divide both sides by tangent, tangent is now on bottom. The rest of the step, everything on the calculator. 4 divided by 33 tangent equals. That's all the work you need to write. So 4 divided by 33 tangent equals, this side is going to be 6.159. Practice that calculator. Do the same problem later when you have some extra time and see if you get the same answers as me. That's all for the last side, which is z. I haven't solved for z yet. So if I pick z and the opposite side, opposite and hypotenuse, which is opposite and hypotenuse here? That's going to be, remember, when you ever hear the opposite, you probably are thinking about sine. Sine of 33 is equal to opposite, which is 4, over z, side z. Oh man, the variable's on the bottom again. Just flip, just flip. If you write the next step as z equals to 4 over sine of 33, I'll take it. That's work. Okay. All right. And when we do this, 4 divided by 33 sine. Oops. 4 divided by 33 sine is going to be z is 7.344. And I bet that if I write this as a Pythagorean theorem, just to double check my work, it's going to work. Okay, I bet it's going to work. If you want to check, 4 squared plus 6.159 squared, this will equal 7.344. Pretty darn close with some decimals. Okay, I got one more thing I need you guys to work on tonight. Okay, there's 2. The next one is going backwards and solving for the angle. Going backwards and solving for the angle. So let's go and give you guys a triangle again. And I know that's a right angle. Call this A, call this B, and I'm gonna give you some sides. I'm gonna give you 3 and 5. And call this C. I don't know what it is. So I'm gonna help you solve for angle A. Measurement, angle A. What does that equal to? Okay, here we go. A, hi A. Once we figure out which angle you want to solve for, please label the sides with respect to A. What is opposite? What is hypotenuse? What is adjacent? 3 is opposite. 5 is and C is my. Now we're still going to use trig ratios. Sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. You have to know, you have to have the right tools to solve these problems. So we're going to choose one of these 3 to make this work. So here's what we do. From A, which sides do we know for sure? I know my opposite must be 3, and my hypotenuse must be 5. Hey, opposite hypotenuse, that's sine. So we use what we know for sure to figure out would I use sine, cosine, and tangent. That's very similar to what we did up here when we try and solve for this triangle here. We always pick the 2 things that we know, and then, well, the one thing that we don't, and that decides, do I use sine, cosine, or tangent? In this case, if I'm solving for A, I have the opposite, I have the hypotenuse, that has to be sine. Three over 5. Now, here's your geometry coming back, here's your algebra coming back. We want to solve for A. We need to get A by itself. And the only way to get rid of that, to do that, is to get rid of sine. Say goodbye to sine. But in math, you can't just cover your eyes and hope it goes away. So we do what we call the inverse operation, and that's sine inverse. Okay? So we're going to do this to both sides. Sine inverse of sine of A. Let me rewrite it, okay? Sine of A is equal to sine inverse of 3 over, 3 over 5. What you do to one side is what you do to the other side. This is like a magic cure. It gets rid of the sign. See you later, that goes away. And we're only left with the letter A, which means angle A. And the rest is calculator work. Now let me explain how to do this on the calculator. You have to type 3 divided by 5 equals. And then you're going to hit shift sign. Again, we're going to first do our numbers, 3 divided by 5. And then we're going to inverse sine. And oh, actually, no, on this calculator, if you look here, inverse sine, you don't have to do a shift. But on many of your calculators at your house, you have to do a shift. Okay? I can show you another calculator right now. But we're going to say 3 divided by 5 equals, then we would have a shift if I didn't have it in this format. Actually, no, I can show you the big version. But let me just finish it. Sine inverse. And the answer is this is 36 degrees. 36 degrees. 36.87 degrees. Let me do that again on this calculator, but this time I'm going to blow it up. Now, if you look at my calculator, sine and sine inverse are actually, see how it's two different things here in one button? So I'm going to type 3 divided by 5 equals, and then I hit the shift. Look at the shift button here. See the shift button here? Shift, and then it allows me to hit the shift inverse, sine inverse. That gives me the 36.86. And that's how you're going to go back to find the angle. Once you find one angle, great. Because once you find one angle, you can find the other one. Oops. So we know now, let me clean up some of the stuff. We know that angle A is 36.87. Hey, we have two angles now. You can find the third because all angles inside a triangle always add up to become 180. So we can say 180 minus 90 minus 36.87. That's going to give me 53.13 degrees. Okay, so we know the other angle now. But I'm going to solve this using, this is my last problem, okay? Last finishing up. I'm going to actually solve for B, not using this triangle sum theorem here, okay? We're going to be using our sine cosine tangent. Let's go ahead and redo this problem. That's solved for B, measurement angle B. That's solved for this guy. So take a stance. If I am standing on B here, what is 3 and what is 5? Is 3 still opposite? Isn't 3 adjacent now? Because it's right next to me. So I can't use opposite anymore. I have to use adjacent. Which of these would be adjacent and hypotenuse? Adjacent and hypotenuse. That would be cosine. So I'd write the question now, cosine of angle B. What's cosine of B? Cosine is adjacent. That's 3. Hypotenuse is 5. And we do the same problem over again. So to get rid of cosine, we do the inverse to both sides. Now, will this answer be 53.13? The world may never know. So we said 3 divided by 5 equals, and we're going to shift cosine, right? We're going to shift cosine that. Shift cosine, 53.13. .13, which is what we claimed that it was going to be. Oh, what happened to it? Disappeared.